Hi everyone, I am Dr. Ravichandar Janapati, Professor, School of Computer Science and Artificial Intelligence, SR University, Warangal, India. Today's course is Foundations to Cognitive Science, and today's topic is top-down and bottom-up processing. In cognitive science, we will discuss these two concepts. Now, in this lecture, we will discuss about top-down and bottom-up processing approaches. So these are the two key approaches in perception and cognition. So the approaches are bottom-up processing as well as top-down processing. These two concepts we will discuss clearly. What is bottom-up processing? Bottom-up processing, it starts with sensory input and brain builds perception step by step from the information received. So your brain will receive perception step by step from the information received. So the examples will be data-driven processing, starts from sensory input, builds perception from stimulus. So in bottom-up processing, data will be taken from the sensory input and it will create a perception from the stimulus. So this is regarding bottom-up processing. So example of bottom-up processing. When we see any unfamiliar object, so first time when we are seeing one object, then how we are going to analyze that particular object. So first we will analyze the shape, color and edges, then recognize it. So when learning, example, when we are learning a new language, we first recognize letters and sounds before understanding the meaning. So in the bottom-up process, first we will take the input that is called sensory input, and from that sensory input we will create the structure. So that is regarding bottom-up approach. So example is when we are learning any new language, first what we will do, we are not able to learn the words. Directly we will not learn words. First what we will do, first we will learn the letters. Then after that we will learn the words. Then after that we can understand the meanings of that particular language. Now coming to top-down processing. Top-down processing. In this particular top-down processing, it uses previous knowledge, experience, and expectations to understand information. So we have previous knowledge, then from that previous knowledge, we will experience something, then from that we are going to expect, or we are going to finalize the things. So this top-down processing is the knowledge-driven processing. Top-down approach is knowledge-driven processing. So, which is based on prior experience as well as expectations. It is a knowledge-based approach which depends on experience as well as expectations. This also interprets sensory input. Finally, it interprets the sensory input. So coming to example, real-time example of sensory input. Like reading unclear handwriting using context. So we are reading some literature or some application or some newspaper or some story. So based on the context, we are going to understand the meaning, even though it is unclear. There is no clear information is there. Some words are missing or something are unclear. Handwriting is not understandable. Then in that particular case also, based on the experience as well as based on the context, we can understand the thing. We can understand the meaning of that particular things. Now, in this, we are going to predict the missing words in a sentence. So it is just, we are going to predict missing words in the sentences. Now, when hearing a familiar song, we are going to predict the next word automatically. So why? Because that is in our experience. That is in our experience. Hence, based on that experience, what we are going to do, based on that experience, we can identify the things. We can identify the things. For example, we are listening some already known song. Already we practice the practiced song or some previously already listen what we already our favorite songs. Sometimes we are going to listen, so easily we can predict the next lyrics. So in what basis? Based on our experience. We already experienced that particular song. We now, so coming to the block diagram of bottom up process and top down process. So the above is bottom up process, where we'll take the input from sensor and we can estimate the thing. Now, in top-down process, based on our experience or based on information processing, we can identify the things. So that is the difference between bottom-up process as well as top-down process. Here we will discuss what is top-down process as well as what is bottom-up processing. In top-down processing, already we have prior knowledge about that particular thing. For example, if one particular hero is there, so already known hero is there. So you can easily process that information. Why? Because that is in your mind. Expectations will be there. So then you can sense the input. Your brain will be interpret. That perception will be stored in your brain. So this is regarding top-down processing. So when you are learning language, some words are missing. In that also you are going to identify are already favorite songs when you are listening. So even though some words are missing or something is missing, there you can predict that particular song. So this is called as top-down processing. Then coming to bottom up processing. Bottom up. In the bottom up processing, first we will take the data from the sensors like ears, what we hear, what we see. So based on that, we are going to take the input. Then our brain will be interpret that particular information. Our brain interprets that particular data. Then we are going to final perception. From that, you can identify the things. So this is regarding top-down processing as well as bottom-up processing. Now coming to top-down processing, it influences that are directed from the brain and mind in an active way, and that shapes what is actually perceived. So that is given to, is that something I have seen before? So this is called top-down processing. Then coming to bottom-up processing. So what you see from that, it influences are built from primary sensor input, like your what you hear or what you see. Both of these processes are operating when we look about us and make sense of the world, what I am seeing. So there is, based on that, your bottom up processing will work. Now coming to top up processing, using models, ideas and expectations to interpret sensory information. Using models, ideas and expectations to interpret sensory information. Is that something I have seen before? Now, coming to bottom-up processing, taking sensory information and then assembling and integrating it. That is called bottom-up processing. Key differences. What are the key differences between top-down processing as well as bottom-up processing. In bottom-up processing, first stimulus, then your brain will be recognized. In top-down processing, first your brain will work, then which can be interpreted. So this is the key difference between bottom-up processing as well as top-down processing. So in bottom-up processing, first your brain will work, then it will be interpreted. Then bottom-up, in bottom-up stimulus, that means you see, what you hear, then that will be given to brain. Finally, bottom-up is data-driven. Bottom-up is a data-driven. Top-down is concept-driven. Bottom-up is a data-driven. What we see, what we hear, so that is bottom-up. Top-down is concept-driven, based on our experience of previous things. So coming to interaction of both processes. So in our daily life, this bottom-up process as well as top-down approach, sometimes it may work individually, but most of the times both process working together. So the final thing is the both process working together. First, only top-down process work individually, bottom-up process work individually. They are not separately work. They will combinedly work. For example, reading the text. When we are reading the text, what will happen? First we see, then we have to understand. Sometimes our brain will work, then we can understand the things. So recognizing faces, sometimes brain will work, sometimes your sensors will work. So both combinedly working together. That is top down and bottom up process. Coming to real time applications. For example, speech recognition. We have speech recognition like Google Assistants, voice assistants will be there, Siri, like that. So in that, it is going to identify the speech. So where first we need to, based on our experience. Next, another one is visual perception. So what we hear. And another one is AI and machine learning systems. So it follows bottom-up processing. So coming to final conclusion, bottom-up builds perception. Bottom-up builds perception from the data. Top-down uses prior knowledge. Both are essential for cognition. Both are essential for cognition. So coming to applications. Applications, understanding how humans perceive organized patterns and wholes. Here, we are going to discuss about Gestalt psychology, principles and applications. Now we are going to discuss regarding Gestalt psychology. Gestalt psychology, principles and applications. So in this, we are going to understand how humans perceive organized patterns and all. Usually, when we observe the things, we are going to observe the things individually, but we cannot interpret as a individual things. We can interpret it as a closed things or just like a object. For example, when you are seeing some object like any gadget or anything, so lot of components are there. They are not, sometimes they are connected, sometimes they are not connected also. There will be a gap, but you cannot see, your mind cannot observe that things as a individual components. It take as a whole. That is called Gestalt principles. Here in the Gestalt principle means understanding how human perceive organized patterns, how he is receiving, how he is observing, and how he is interpreting that as a complete thing. Now, coming to Gestalt psychology. This Gestalt explains how the brain organizes visual information into meaningful patterns. How the brain organizes visual information into meaningful patterns. The whole is greater than the sum of its parts. The whole is greater than sum of its parts, like Olympic rings. Olympic rings actually they are not connected, but where there are different rings will be there, but we cannot see as a different rings. Our mind will observe or perceive it as a one picture or one symbol, as a one logo, even though we have different circles. We see connected pattern, not separate circles. In Olympic rings, this is the best example. We see a connected pattern, not separate circles. So this Gestalt psychology developed by Max Wertham, Wolfgang, and Kurt Kofka in early 20th century. Objects placed close together are perceived as a group. We are not considering as a individual things. We will consider as a group. For example, students sitting together in a classroom are perceived as one group. For example, there are different students are there, boys, girls, or different age groups or something. Even though if they are sitting in a classroom, we are perceived as a one group. We are not considering it as a individuals. We are considering they are as a one group, that is one class. If they are sitting in a particular room, one room. Now, here in this Gestalt psychology, it follows some laws. In that, first law is law of proximity. What do you mean by proximity? That means closeness. Proximity means close together. So the object placed close together are perceived as a group, like students sitting in a classroom are perceived as one group. Then another law is law of similarity. Law of similarity. Objects with similar color, shape, or size are grouped together. Objects with a similar color, shape, or size are grouped together. Like football team wearing same jersey looks like one group. In a football team, they wear same color jersey. So we consider it as a one team because they wear similar t-shirts. Law of continuity. Next one is law of continuity. Law of continuity. Usually, our eyes follows the smooth and continuous paths. Road markings guide driver smoothly. Usually, road marks will guide the driver smoothly. Next, another one is law of closure. In this law of closure, our brain fills missing parts to perceive complete objectives. Our brain fills missing parts to pursue complete objects. So that is called law of closure. Brain automatically completes missing parts. Our brain will completely automate. For example, we are going through one path. Even though that line is not filled, our brain will take it as a complete path. In some image also, even some part of the image is missing. So our brain will fill with our previous experience. Then another one is figure ground principle. Figure ground principle. So usually humans separate objects from the ground. So they can easily identify what is figure, what is background. Now, coming to these things, proximity, when objects placed together, they are perceived as a one group. Similarity, when objects look like similar one another, the eye perceives as a one group. Like the same color t-shirts wear by football team is as one group. Proximity, in a classroom, the sitting students will consider as a one class. That is next continuance. So the eye compelled to move from one object to another. Next closer. when an object incomplete or not completely enclosed. Then coming to figure and ground. When the eye differentiate an object from its surrounding areas. When the eye differentiates an object from its surrounding areas. Law of common fate. Law of common fate. Objects moving in the same direction are perceived together. Objects moving in the same direction are perceived together. Applications in design. So usually these are used in user interface or user experience logos, advertisements, and dashboards. So what are the applications in cognitive science? Coming to the applications in cognitive science, there are a lot of applications, including perception, pattern recognition, human-computer interaction, and artificial intelligence. So what are the real-life examples? Like traffic signals, logos, mobile apps, and data visualization. These are the real-life examples. So, in summary, Gestalt's principles explains how humans naturally organize visual information. So, this will be explained by Gestalt principles. How humans naturally organize visual information. Organization of visual information plays a vital. So from this, in today's lecture, first we have discussed regarding bottom-up and top-down processes. Bottom-up means which starts with sensory input and the brain builds perception step by step from the information received. So that is called bottom-up processing. Like seeing an unfamiliar object first time, analyzing shape, color, edges. These are comes under bottom-up process. Now coming to top-down processing. Top-down processing uses previous experience and expectation to understand information. This top-down processing is knowledge-driven processing. It uses prior experience, expectations, and interprets sensory input. So coming to example of top-down processing, reading unclear handwriting using context. Then we have discussed Gestalt Principles. Gestalt Principles explains how the brain organizes visual information into the meaningful patterns. Just like in the Olympic rings, we, even though that are different rings, we see it as a one information. So finally, in the Gestalt Principles, the final conclusion is this gives how humans naturally organize visual information. So, thank you.